Hello everyone, welcome to the Mobile Space Shooter course. To start with the course, let's choose optimal project settings. So first open your Unity Hub and go to Installs. Here you can find all installed Unity versions on your PC. I will use the Unity 2022 version for this course, so the best way to follow this course is to use any 2022 or newer version. Also, make sure that you have Android or iOS modules installed. To install modules for the Unity version you need, click on the Settings button and Add Modules. Then choose Android or iOS or both and continue with the installation. As you can see, I already have modules for the 2022 version. Now go to Projects, New Project. First select the Unity version. Then you can see some project templates. You can see there are 2D and 3D mobile templates. These templates come with a bunch of packages that you need for mobile games, but often you will not use them all. So instead I prefer to create basic 2D or 3D projects and then manually import packages that I'm sure I will use. This is a 2D game, so select the 2D basic template and choose a name and location. Then we can create a project. You should see something like this. The first thing we need to do is to switch the target platform to Android or iOS. So go to File, Build Settings. By default, the target platform is Windows, Mac and Linux. This is a mobile game, so I will select Android and click on Switch Platform. Wait a moment for Unity to do the job. Nice, this is a basic project setup. In the next video, we explore a very useful feature, Device Simulator. See you in the next lecture. Hello everyone, after the basic project setup, let's explore another cool feature that will help us develop a mobile game. It's a Device Simulator. To open it, select the game window, expand the list, and here you can switch to the simulator window. You can also find it if you go to Window, General and Device Simulator. The simulator will show you how the game will look on a certain device and you can test gameplay with the mouse. If you expand the device list, you can see a couple of devices that you can select. I recommend that you install additional devices, it will give you a lot more options to choose from. Of course, you can play with some settings. You can scale the view or choose Fit to Screen. You can rotate the screen, and this safe area is for the navigation of UI elements. Feel free to choose the device you want. I will go with Samsung Galaxy S10 5G. Now when everything is in place, in the next video we will import project assets and slice some sprites. See you there! Hello everyone, let's continue with the course and import some sprites. Organization of the workspace is very important, so let's create a new folder for sprites. Make sure you select the asset folder, right click, create, folder. I will call it sprites. Open it. Now you can download the sprites from the resources. Use some tools like WinRAR to extract files. As you can see, sprites are organized in folders. Select them and drag them into the project. Feel free to explore sprites. For now, let's select the player sprite. In the inspector window, we can see sprite settings. Let's expand this part at the bottom to get a better preview of the selected sprite. For most sprites, including this one, default settings are good. We don't need to change anything. We can select the scene view and place the sprite in the game. However, some sprites need changes. For example, in the enemies folder, we have two enemies in one sprite. We need a way to slice this sprite into two parts. So select the sprite, change sprite mode from single to multiple, then go to the sprite editor and apply changes. In the sprite editor, in this case, sprites might appear a bit blurry, but don't worry, That's because they are upscaled for preview. Because it's a mobile game, usually dimensions are small as possible to optimize performance. Okay, to slice sprites, go to Slice, choose Grid by Cell Size. I know that one cell size for this sprite is 128 pixels. How do I know that? In this project, every sprite has dimensions included in the name. For example, this sprite is named Enemies 128. So if you make your own sprites or you hire some artist, make sure that you know the precise dimensions of the sprite and grid. I like to place dimensions in names. Okay, set pixel size to 128 for X and Y. Click Slice. You can see two separate cells, each containing one enemy. Apply changes and exit the sprite editor. We can delete the previous object. Now, when you expand the sprite, we can use each enemy separately. Another example is this explosion effect. We need to slice it. Also, in the inspector, you can read the full size of the sprite, which is sometimes important to know. Now repeat the process. Cell size is the same. This explosion effect will be used later for animation. Here comes your first mini challenge. You can go through other sprites that need slicing. So slice just sprites that have multiple objects placed in a grid. You don't need to slice simple sprites. After you finish, see you in the next lecture. Hello everyone, let's make a scrolling background. This is the final result, and the goal is to create the illusion of the ship moving. The ship is not actually moving, the background moves. Okay, first go to the backgrounds folder. Let's choose this background sprite. Under the transform component, you can see the position, rotation and scale of the object. We need a 0, 0 position. You can just set it manually by writing 0 to X and Y values, or click on 3 dots and click Reset. Notice that we don't see spaceship anymore. It's rendered behind the background. So select the ship. The sprite renderer component is responsible for a visual representation of the object. Expand additional settings. Here you can see the sorting layer and order in the layer. Important, don't mix sorting layers with these layers here. Sorting layers are for visual stuff and layers up here are for physics and collision stuff, which we talk about later in the course. Anyways, you can create new sorting layers, but in this case let's use the default one. We only need to increase the sorting order. The sorting order of the background and the player is 0, but if we increase the sorting order number of the player will be in front. I will set it to 10. Let's see how it looks in the simulator. The camera is a bit too close, so select the main camera and increase the size. This looks good for now. Okay, let's rename the background. Now with Ctrl D, duplicate it. Press W to use the Move tool and move the duplicate up a bit. Now press V and click on the bottom left vertex. Drag it down to the other background and it will snap perfectly into position. In the hierarchy, drag the duplicate background onto the original one. Now the original will be a parent and the duplicate will be a child object. Let's rename it. The next step is to create a new script. Let's stay organized, so let's create a new folder for scripts. Now let's create a new C# script called Parallax. Select the parent background and add the script. You can also use Add component to add the script. Now open it. First, let's create some variables. I will use the attribute serialize field for the private float variable parallax speed. Now, even when the variable is private, I can access it in the inspector. We also need private float sprite height and private vector3 start position. By default, you should see two functions, start and update. Start is called only once when the object is enabled. That usually means when the level starts. The update function is called repeatedly every frame. We use start to initialize variables. So when the level starts, let's store the position of the background in our vector3 starting position. So start position gets the value of transform.position. Note that transform is a component on the object. Also, let's use sprite renderer to get sprite height. We use getComponent to get access to the sprite renderer component and get the Y size of the sprite. If you want to remind yourself how to use the getComponent function, I will put a link to my YouTube tutorial where I go into more detail about getComponent. That's all for the start function. In the update, the goal is to move the background down a little bit every frame, so we use transform.translate function. We need to move down, so let's use vector3.down for the direction, then multiply it with the parallax speed. In the end, multiply all with time.delta time, so the movement looks smooth and even. Of course, now the background will go down infinitely. After a certain distance, we need to reset the position. So if the current position on Y is less than starting position minus sprite height, that means the background moved more than one full height of the sprite, then we need to move it up instantly to the starting position. In that way, we get a loop effect. Okay, that's all we need to code. In the inspector, choose parallax speed and click play. You can see how it works in the scene view. And this is how it looks in the simulator. Nice. Now let's take this background. Let's press V and drag this corner. It should snap and align perfectly. Since this part is a bit transparent, it can be in front of the player, so set the order in the layer to 11. You can see that looks nice. Rename the second background. Duplicate it. Rename it. And move it up just like in the previous example. Also make it a child object. On the parent object, add the parallax script and choose speed. Let's see how it looks now. Nice. To better organize the hierarchy, we can create an empty game object and reset the position. Select two background bases and drag them under the backgrounds object. Great. Now here is your mini challenge. We have one more background and stars to add. Just repeat the process and don't forget to change the order in the layer. Here is the end result. Under backgrounds we have 4 objects. The sorting order for the third background is 1 and for the stars is 2. That's all for this lecture. See you in the next one. Hello everyone, in this video we import a new input system and adjust some settings. The first thing we need to do is to go to Window, Package Manager. By default, you should see all packages that are already in the project. To show you all available packages from Unity, go to Packages and select Unity Registry. From the Unity Registry, we can search for the input system, select it and click on the Install button. To finish the installation process, Unity will restart. After that, if you go to packages in the project, you can see that we have the new input system on the list. Exit the package manager. To make sure it's correctly installed, we can go to Edit, Project Settings, select the player, and expand other settings. Scroll down. We are looking for active input handling. You can see the old system, the new system, and both options. Make sure that the new system or both are selected. I will select both. Nice. We have one more thing to do. To simulate touch on the screen with the mouse, we need to go to Window, Analysis, Input Debugger. Go to Options and enable Simulate Touch Input from mouse or pen. Now we can use the mouse with the simulator. And that's it for the basic preparations. See you in the next lecture. Hi everyone, let's explore the new input system. The new input system is super flexible and can be used in many ways. From Unity, we can see that touch support is divided into the low-level support in the touchscreen class and high-level support in the enhanced touch class. The enhanced touch class has more options and control. It's designed for pulling in the update function and Unity recommends using it. So for this project, we will use the enhanced touch class to control input. Once you know the syntax and theory behind it, touch control becomes really easy. Okay, first we need to enable enhanced touch. Usually we do it in the onEnable function. Also, we need to disable it in the onDisable function. It's pretty simple syntax. Then the enhanced touch provides access to information along two dimensions, by finger and by touch. So how we define finger and touch? Each finger is defined as the end contact on a touchscreen. For example, we touch the touchscreen with one finger, doesn't matter which one, that is the first contact, and some information is stored in finger 0. If we touch the screen with two fingers, information is stored for both fingers, finger 0 and finger 1 variables. The fingers that are touching the screen are stored in the active fingers array. So to get the information, we use the following syntax: touch.activeFingers. Since this is an array, to get the information from the first finger that is touching the screen, we use index 0. To get the second active finger, if it exists, we use index 1, and so on. Okay, there is one more array we use, and that is the fingers array. Notice there is no keyword active. It is the array of all possible fingers that can touch the screen at the same time. Usually this array has 10 elements for 10 fingers, but it can be lower depending on hardware and software. To use this array, we must check for an additional condition. We need to check if the finger from this array is active. If that is true, then we can use it. In the next example, I will demonstrate the difference between these two arrays. This is really important, so take your time to understand this. Let's say we touch the screen with two fingers. This will represent the active fingers array, and this will represent the fingers array. Now we need to get some data, maybe the position or something else. Let's say this is the first finger that touched the screen, so it has index 0 for both arrays. That means this finger has index 1. Now, if we, for example, lift the finger with index 0, in the active fingers array, the finger that had index 1 becomes the finger with index 0. However, in the fingers array, indexes stay the same, but this finger 0 is no longer active. When we lift all fingers from the screen, everything resets. To conclude, it's important from which array and from which index we get data. Now let's take a look at the touch. When you touch the screen with a finger, Unity will store some information in the touch structure. The touch structure is easiest to explain using phases. Every touch has began and ended phases. The began phase happens in the first frame when a finger touches the screen. The ended phase happens when we lift the finger off the screen. Between those two phases, we can also have the moved and stationary phases. Of course, the moved phase is when we move our finger on the touchscreen, and the stationary phase is when we don't move our finger. There is one more phase called cancelled. It happens when we have a touch and we move away focus from the application. Moving away or losing focus happens when we minimize the application. These phases are very useful and we will use them in the course. Also, there is an active touches array that we can use to get active touches, similar to the active fingers array. Okay, that was a little bit of theory about the enhanced touch class. Let's use it in the next lecture to create player movement. Hello everyone! In this lecture, we will learn how to move the player using the new input system and touch controls. To start, go to the scripts folder, create a C# script. I will call it player controls. Open it. The first step is to add the input system enhanced touch namespace. As we said in the previous lecture, we need to enable enhanced touch. We do it in the onEnable function. Remember, that function is called whenever the object is enabled. Then we disable it in the onDisable function. That happens when the object is disabled, destroyed, and so on. Next, we need to receive inputs in the update function. For this game, we need just one finger. The best option is to receive inputs just from the first finger that touches the screen. It doesn't matter which one physically, just that it is the first one. So in the if statement, we write touch.fingers with index 0. Index 0 means the first finger. You will notice one error. This is because this touch structure can be used from multiple namespaces. So we need to specify which namespace to use. We can right-click on the touch and open Quick Actions. You can see that we can use two namespaces, UnityEngine.touch and UnityEngine.enhancedTouch. We need to use enhanced touch. Now, at the top of the script, you should see that every time we use touch, it is from the enhanced touch namespace. Now we can continue with the if statement. We need to check if the first finger is active, which means that it touches the screen. Then we can use touch to get the first active touch from the active touches array. We know that this active touch will come from the first finger on the screen because of the if statement. From active touch, we need to get a position. First, we use vector 3 to store the screen position of the touch. Since this is a screen position, we need to convert it to a world position. Screen position is a position on the screen. It's different from the world position. The world position is the actual position in the scene and game. That is what we need. For conversion, we use the main camera. The main camera has the function screen to world point. So we give it a screen position, convert it into a world position, and then store it again in the touch position variable. We can also store the main camera in a variable for better performance. Let's create a new camera variable. In the start, let's set the main camera to camera.main. Now we can use the main camera variable in the code. Then we can set the position of the player using the new vector 3. For x, we use touchPosition.x and touchPosition.y for the y position. Position on z-axis doesn't matter, it just needs to be in front of the camera. I will set it to 0. Let's try this. In Unity, select the player and add the player controls script. Press play. I can click on the spaceship and move it across the screen. However, if I click somewhere on the screen, the spaceship will teleport to that position. This is not the behavior we need. Idea is that the player doesn't need to click on the spaceship to move it. The player should be able to click anywhere on the screen and move the spaceship from its position. In that way, the player has more visibility and control over the screen. For example, if I click here and the spaceship is here, and I move the finger down, I want that spaceship also goes down from its position. To implement that behavior, we need to calculate the distance between the touch position and the spaceship. Let's go back to the script. Create vector3 offset that we will use as a distance from the touch to the spaceship. As you know from the previous lecture, touch has phases. If we just touched the screen, at that frame touch phase is began. So let's check if the phase of the first active touch is began. Notice there is an error. We also need to specify namespace for the touch phase. We use the input system.touchPhase namespace. Then, to calculate offset, we use a bit of vector math. Offset is equal to the touch position minus the position of the spaceship, and that is transform.position. This will give us the distance we need. Then we can check if the phase is equal to moved. That means if the player moves the finger on the screen. Of course, then we need to move the spaceship, so we can use this code with one modification. Subtract offset x from the x coordinate and offset y from the y coordinate. There is a phase when the player is touching the screen and is not moving the finger. So if the phase is stationary, then do the same thing. Set position with offset. And that is all we need to code. Let's try it. First, let's try clicking on the spaceship. That works fine. Then click anywhere on the screen and try to move the spaceship. You can see that the spaceship follows the touch correctly. This is what we wanted. Of course, there is a possibility to go off the screen. In the next lecture, we will address that situation. See you there! Hello again. Let's make some movement restrictions for the player so he can't go off the screen. Idea is to use viewport. Let's take a look at the mobile screen. The viewport space is normalized and relative to the camera. What that means is that values go from 0 to 1. For example, the coordinates of the bottom left corner are 0, 0. The first number is for the x value and the second number is for the y value. The coordinates of the upper right corner are 1, 1. The bottom right coordinates are 1, 0 and the upper left 0, 1. The center point is 0.5, 0.5. We will use those coordinates and convert them into world space. Then tell the player that he can't move past those coordinates. Okay, now that we know the idea, let's start. Open the player controls script. First, we need private float values for maximum left, right, down and up points. In the start, we can assign those values using the viewport to world point function. So the max left gets a value from the main camera that viewport to world point. As I said, we convert viewport to world point. Now we need to pass viewport coordinates, so we use the new vector2. Since this is the maximum left position, for the x value, let's try with 0.15. And for the y, we can use 0. You will see an error. It's because this function returns vector3 and we are storing it in float value. But we only need an x value from the vector, so at the end write .x. For the maximum right, the process is the same, just change the x value. To make it symmetrical, 1 minus 0.15 is 0.85. For the max down value, the process is similar. Now the x-coordinate is 0 and the y-coordinate can be a small number, for example 0.05. In the end, we choose the y value with .y. The max up value will be 0.6 because I don't want the player to move all the way to the top of the screen. Okay, now that we know the restriction coordinates, let's apply them. Go to the update function. I will just zoom out a little bit because this will be a long line of code. Now inside the main if statement at the bottom, override the position with the transform.position. New vector 3. To restrict values, we use the mathf.clamp function. First we write the value we want to restrict, and that is the x position of the player. Then we write the minimum value, in this case that is the left side of the screen, so the max left position. Then we write the maximum value, that is the right side of the screen, in this case max right. For the y coordinates, we want to clamp transform.position.y. The minimum value is max down and the maximum value is max up. For the z-axis, we can just write 0. I think this is all we need to code. Let's try it. You can see that now the player can't get off the screen. Maybe we can increase the bottom coordinates a bit. You can also see that I can't move above 0.6 of the screen. Of course, you can go to the script and increase the max up value. Now I can move all the way up. Feel free to experiment with the values and find the best for your game. This will work for any screen size on any device. You can try it on other devices in the simulator. Nice, that's all for this lecture. See you in the next one. Hello everyone, in this lecture we will adjust our camera for all types and sizes of screens. At this point the camera size is good, but on a different mobile device maybe it will be too big or too small. To solve this problem we use Cinemachine and a virtual camera. So let's import the Cinemachine package, go to Package Manager and select Unity Registry. Find Cinemachine and install it. Now let's create a virtual camera. You can reset the transform component and set the z-axis to a negative value. In that way, we make sure that the objects are in front of the camera. Notice that now we control the camera size on this virtual camera. Idea is to create two empty objects on the side edges of the screen and then make sure that those two objects represent the edges of the camera regardless of the device. So they always need to be inside the camera view and act like edge boundaries. Let's create a new empty game object. I will call it a left point. We can give it an icon. Then reset the transform component. Move the object to the left. I think that -4 is a good value. Don't go all the way to the edge. Then duplicate the object. This will be right point. The value for x needs to be symmetrical, so it's 4. Now we need a new empty game object. Call it target group. Reset the position. Then we can add the script from the Cinemachine package. Add the Cinemachine target group script. You can see that we can add target objects to the list. We need two targets. One is left point and another is right point. Great. Now select virtual camera. Drag the target group into the follow and look at fields. Since we are using a group of objects, for the aim, select Group Composer. We need to change a couple of options. The first one is Group Framing Size. It defines how much screen space is taken up by the bounding box of the targets. We need to set it to 1 so that the edges of the screen are exactly on left and right points. Then set Frame Damping to 0. The lower value, the faster camera will adjust itself to the correct size when the level starts. Now you can try it in the simulator. Change devices and see how the game looks. It should be fine. However, there is one hidden problem. Notice that movement restrictions are not working correctly anymore. The reason is that we set restrictions in the start function, but the Cine machine didn't have time to set the camera correctly at the start of the level. So the viewport from which we get coordinates sends wrong data. The solution is quite simple. We can use coroutine. With coroutine function, we can delay the execution of code. The syntax is a little bit different. We need to create the IE numerator function. In the function, the code is kinda separated into two parts. In the first part, we do something or nothing, depending on what we need, in this case nothing. Then we add time delay. We write yield return new and then choose how long the delay will be. For example, we can wait for end of frame, we can wait for certain amount seconds, and so on. Let's wait for 0.2 seconds. After time passes, we execute the second part of the code. In this case, we need to get restriction values. Those 0.2 seconds is enough time for Cine machine to adjust the camera, and then we get the correct viewport data. Actually, let's use wait for end of frame for this example. We expect that one frame is enough time to adjust the camera. The last thing, we need to call this function with start coroutine. Use start coroutine in the start and call the setBoundaries function. Let's try it now. Everything works fine. Note that sometimes Cine machine needs more time to adjust the camera, for example on older mobile devices, so maybe it's smarter to have more time delay. That's it. I hope you understood everything and see you in the next lecture. Hi everyone, in this lecture we'll learn how to create enemies using the inheritance concept. The best practice to use inheritance is when you have a group of objects that have a lot of common functionalities, for example a group of enemies. The concept is very simple. We create a parent, also known as a base class. Then we create child classes. Child classes will inherit variables and functions from the parent class. In addition, child classes can have their own variables and functions. Let me show you an example. First, to stay organized, select the scripts folder and create a new one for enemy scripts. Then let's create a new C# script. Call it enemy. It will be our base class. Open it. Okay, all enemies need to have health that is common for all of them. So create a public float health variable. Now we can create a child class. For example, Meteor. Open it. To make this a child class, replace monoBehavior with the enemy class. For now, leave the child class like this, no variables or functions other than start and update. In Unity, we can create a new empty game object, add the Meteor script, and we can see the health variable. The health variable is inherited from the enemy class and we can use it in the meteor class. Let's go to the enemy class. Usually we can use protected variables instead of public ones. Protected variables are something in between private and public. They are visible just to parent and child classes. Other classes can't see or change them directly. That also means we can't see them in the inspector by default. For that, we use serialize field. Nice. Let's take a look structure a bit more. We have a parent class enemy, child meteor class, and we can, for example, create a spaceship child class. So both meteor and spaceship need to have health. They need to have a rigid body, probably an animator for animations and so on. All that stuff that is common goes in the parent class. Also, all enemies can take damage, so we can create the take damage function in the parent class. Child classes will inherit those variables and functions. As I said, in addition, we can have specific functions just for child classes. The meteor class can have, for example, rotate function, and spaceship can have a shoot function. And that is the basic logic of inheritance. Now let's go to the enemy script and create the take damage function. Make sure that is public because other classes will call this function. Also, it needs to take one float damage parameter. In this function, we will decrease health with the damage value. Then we can later add some damage animation. After that, we can check if the health is less or equal to 0. Then we can maybe play a destroy animation. Later we will write actual code for that. Now I will show you one advanced trick with virtual functions. Virtual functions work really well with inheritance pattern, so we create a virtual function in a parent class. All child classes can use that virtual function, but can also override it. That means adding some code and functionality. Let's see the syntax. We create a public virtual void function. Notice the keyword virtual. Let's call it hurt sequence. And we can also create that sequence. Now replace comments with functions. When the enemy takes damage, the hurt sequence happens. That sequence happens when the health is less or equal to 0. We can add some functionality to virtual functions if we need. In this case, we don't need it. Let's go to the meteor script. Since this class is a child class, we can override virtual functions. Notice the keyword override. By default, code from the base class will be called. So if you have something here in the virtual function, that will be called. But remember that we don't have to call it, it's an option. So we can just delete that line of code. We can do something different and unique for this child class. In that way, every child class can have different hurt and death sequences and behavior. For example, one enemy type can explode in the death sequence. Another enemy type can, for example, explode and also spawn more enemies. The possibilities are endless. Okay, that is all theory we need to know. Through the course we will add more stuff to the base class enemy. In the next lecture we will apply this knowledge and make the first enemy. So see you there. Hi everyone, in this lecture we will create meteor prefabs that can destroy the player. First we can delete the meteor object from the previous lecture. Then we can go to enemy sprites and drag one meteor into the scene. We can rename it. To make sure that enemies are visible in front of the background, increase order in layer. Notice that the player is too big, it would be too hard to avoid meteors and projectiles. We can change the scale, maybe to 0.6. Great, now select meteor. To put this object under influence of the physics engine and forces, add the rigid body to the component. We will move meteor using this component in the script. Notice there are some settings like gravity. If we press play, the object will fall. To actually collide with other objects, we need a collider, in this case Circle Collider 2D. Let's zoom in to see better. I will decrease the radius a bit. Perfect. We also need to add rigid body and collider components to the player. Add rigid body 2D. For the player, we can set gravity to 0. The player has more complex sprite, so we can add polygon collider 2D. To increase performance, we can remove some lines from the collider. Click on the Edit Collider button. Now hold Ctrl and click on the line when it becomes red to remove it. We can also move some vertices. I will speed up a bit. You can edit the collider as you wish. It doesn't need to be the same as mine. We can exit edit mode. Now select the meteor. To avoid selecting the background, we can disable selection. Move the meteor to the middle. Now we can test collision in the play mode. As you can see, objects collide. The next step is to enable the Is Trigger option on the Meteor Collider. Now the objects will not collide, but collision is detected and we can use it in the script. Next, change the rigid body type to kinematic. Now other objects and forces can't affect this object, which means nothing can push or pull this meteor. We can control movement only through the script. Also, remember, any object that has a collider and you intend to move, destroy or change it needs to have a rigid-bodied component. We can add the meteor script and move it up in the inspector. Open it. Before we start coding here, let's go to the parent enemy class. All enemies will have a rigid-body 2D component, so we can create a protected variable RB. In Unity, you can drag the rigid body component into the empty field. Now go back to the meteor script. I want to create meteors with different and random speeds. So create two float variables that we can see in the inspector. One is minimum speed and other is maximum speed. And we also need one private float speed. In the start function, we can set the speed. Speed will get value with random.range. So the value will go from minimum speed to maximum speed, which we set in the inspector. Now we need to add velocity to the meteor, so we use rigid body rb.velocity and set it to vector 2 down, which means a negative value on y-axis, it's -1. The meteor will move down and we just need to multiply direction with speed. In Unity, set minimum and maximum values. Let's test it. Nice. Now let's detect a collision between the meteor and the spaceship. We use the onTriggerEnterToD function. This function will be called when something enters the trigger that we have on the meteor. You can see that the function has one collider2D parameter. Let's rename it to Other Collider. Later we will have a damage system and we would damage the player, but for now let's just destroy the player. We use the function destroy, and we want to destroy other collider.gameObject. So this is the object meteor collided with. Let's see it. Nice. However, the meteor can touch other objects, so we want to specify just to destroy the player. There are many ways how to do it. We will use tags. Select the player and go to the tag dropdown. Select the tag player. Of course, you can create a new tag here. Just click on the plus button. I will not do it now. Just make sure that the tag player or whatever you use is selected. First, we want to check if the object has the tag player with the compare tag function. If that is true, then destroy it. Great. Now we need to create a prefab from that meteor. It's like a copy of the object with all its components. First, let's create a new folder, prefabs. Then drag and drop the meteor object from the hierarchy. Now we can easily create copies of that object in the scene. We will use this prefab for the spawner in the future. If you go to the enemy sprites, you will see 2 more meteors. Your mini challenge is to create prefabs from these sprites. The solution is very simple. You can repeat the process to remember everything we have done, but there is an easy way to do it. We can select the prefab from the hierarchy, replace the sprite, rename it, and drag the prefab into the prefabs folder. We want to create a new original prefab. Then do the same to create a third prefab. And that is all for this lecture. See you at the next one. Hello everyone. Before we make a spawner for meteor prefabs, I will show you one useful trick about collisions between objects. We will explore the collision matrix. Using the collision matrix, we decide between which layers the collision will be detected. So first we need to create more layers, select the player and go to the upper right corner in the inspector. Remember, here are layers for collisions. We already have some default layers, but let's create new ones. Go to add layers. Let's create the layer player. We can also create one for enemies. Now select the player and assign the layer that we made. Next, we can select the meteor prefab from the hierarchy. The meteor should be on the enemy layer. For prefabs, it's important to override changes if you want to apply them to the other instances of the same prefab. Now, if you go to the prefabs folder, select meteor 3 and you can see that he is already on the enemy layer because of the override we applied. Now select the other 2 meteors and change the layer to enemy. Since we made changes directly to the assets, we don't need to override anything. You do overrides just when making changes to prefabs in the hierarchy. Now go to Edit, Project Settings, and select Physics 2D. Go to Layer Collision Matrix. Here you can see all the collision layers and relationships between them. By default, a collision between all layers is enabled. You can also see the layers we made. To disable collision between layers, just uncheck the box. In this case, we disabled the collision between the default and enemy layers. So we can continue disabling collision until we get to the layer player. We need a collision between the player and enemies, so leave that checked. Next, we don't need collision between enemies. For the layer player, also disable other collisions. Just to show you, if you disable collisions between the enemy and the player, the meteor will go through the player and collision will not be detected. So make sure collision is enabled. This is a nice way to control what will collide and what won't collide. You should definitely use this in your projects. Later in the course, we will add more layers and modify this matrix. That's all for this lecture. See you in the next one. Hi everyone, in this lecture we will create a spawner for meteors. We also make sure that meteors spawn outside of the screen and inside the left and right edge boundaries. First, let's create a new empty game object. This will be meteor spawner. We can reset the transform component. Then we need to create a new C# script. Call it meteor spawner. Add the script to the game object and open it. Now let's create some variables. We need an array of game objects. This array will hold meteor prefabs. Then we need the spawn time variable. This variable will determine when meteors will spawn. We need a timer to keep tracking time. And the integer variable I as an index for the array. Next, we need a reference to the main camera. Of course, we need max left and max right variables for screen edges. And in this case, we also need a Y position variable that will be outside of the screen to make sure meteors spawn at the right position. In the start function, let's set up a reference for the main camera. It's the same way as we did in the player controls script. We can also go to the player controls script. Here we can copy the setBoundaries function. Let's paste it into the spawner script. We can delete the max down and max up variables. We use max left and max right variables. Feel free to tweak these numbers if needed. We need to add one variable, and that is Y position. That position needs to be outside of the screen, so for the Y value, use something greater than 1. I will use 1.1. Next, call this function in the start with start coroutine. Now let's create the main logic of the spawner, calculate time and spawn meteors. By default, the timer is 0, but we can make sure and set it to 0. Then we increase the timer by time.delta_time. Time.delta_time is the time between two frames. As we update frames, the time will increase. Then we check if that timer is greater than our spawn time. If that is true, we need to spawn one of the 3 meteor prefabs. So we set the index I to random.range, which goes from 0 to meteor.length. In this case, the index will be number 0, 1 or 2. Now, when we have an index number, we can spawn a meteor prefab from the array. To create objects at runtime, we use the instantiate function. First, we write the object we need to spawn. In this case, that is a meteor prefab from the array with index I. Then we choose the spawning position. We need a new vector 3. For the x value, we use random.range. It goes from max left to max right. This will spawn meteors within screen edges. For the y value, we use y position. Remember, the value is above the top of the screen. For the z-axis, we use any number that will put the object in front of the camera. I think that our camera is -10, so we can go -5, for example. Next, we need to set the rotation of the object. To choose the default rotation, we can just use quaternion.identity. But to make it look better, let's use random rotation. We set the rotation using quaternion.Euler. X and y values need to be 0, and for rotation on z-axis, we use a random.range between 0 and 360. Then we need to reset the timer to 0. Great. Let's go to Unity. We can choose spawn time. For example, I will set it to every 2 seconds. Then we can add meteor prefabs to the array, log the inspector and go to the prefabs folder. Select meteors and drag them to the array. Make sure that you use prefabs from the assets, don't use prefabs from the hierarchy. Let's try it. Nice, everything works. However, we need to take care of one problem. I will increase the spawn time and play the game a little bit. You can see in the hierarchy that we have a lot of objects. Those are meteors that we avoided and they are falling to infinity. To solve this, let's go to the meteor script. We will use the function on became invisible. This function will be called when the object is no longer visible to the camera. In other words, when the object leaves the screen. Then we just need to call the destroy function and destroy this game object. Let's test it. Now you can see that meteors are destroyed as they go off the screen. Nice. To make this spawner even better, we can randomize the size of the meteors we spawn. In the spawner script, let's store the object we spawn in the game object variable. Then we can create a random variable for the size of meteors. I will set a really small range, you can increase the difference if you want. Then we change the local scale of the meteor. For x and y, use the variable size. Great. This is all we need to code here. See you in the next lecture. Hello everyone! Before we add shooting ability to the player, I decided to squeeze in this lecture about meteor rotation. This is optional, but I think that meteors will look better if they rotate. The goal is to rotate meteors on z-axis in the script. Let's delete this prefab from the hierarchy. Open the meteor script. First we need float variable rotate speed. Then in the update function we need to rotate the object every frame. We use the transform.rotate function. For x and y axis we don't need rotation. And for z-axis use rotate speed and multiply it with time.delta time. We use time.delta time so that the rotation looks nice and smooth. This is all we need to code. In Unity, select meteor prefabs and set rotate speed. Let's try it. Nice. I think that this looks much better. That's all for this lecture, see you in the next one. Hi again. Let's add shooting ability to the player. In this lecture, we will create basic shooting from one shooting point. Upgrades and shooting from more points are done later in the course. First, we need a position from which we will shoot. So right-click on the player and create an empty game object. This object is a child object of the player. I will call it basic shooting point. We need to move the shooting position a little bit above the spaceship. Then create a new C# script. I will call it player shooting. Open it. As always, first let's create the variables that we need. We need one game object variable for the laser bullet prefab. We need a transform point from which we shoot. Then we need the shooting interval variable. Also, let's create one float variable so that we can reset the interval. We set this shooting interval value in Unity in the inspector, and then in the start function we can store that value in the interval reset variable. Next, there are many ways how to create timers. We already made one for the spawner, but for this case, let's create a timer by decreasing the value. Every frame we decrease shooting interval by time.delta time. If that shooting interval is less or equal to 0, then we can shoot one laser bullet. Before we create a function for shooting, let's just reset the interval by setting it to the default value. Next, create the shoot function. To spawn objects, we use instantiate. As you remember, first we write the prefab we need to spawn, and that is laser bullet. We need to spawn it on the basic shoot point position. We can use default rotation and use quaternion.identity. Then call the function when the interval is less or equal to 0. In Unity, select the player and add the script. You can see that we need to set up some references. For now, we don't have a laser bullet prefab, but we have a shooting point. Drag the point that we made at the start of the lecture. We can also set the shooting interval to 0.3 seconds. Now let's create a laser bullet prefab. Go to Sprites, Player, and here you can see the projectile sprite. Let's drag it into the scene, rename it. It's a bit too big, so set the scale to 0.5. Then add the rigid body 2D component. Choose the kinematic body type. Next, we need a collider. I will use Capsule Collider 2D. Let's adjust the collider a bit. It needs to be smaller. Then enable the isTrigger option. Now let's create a new collision layer for projectiles. Go to Add Layer. I will call it Player Projectiles. Select the object and choose the Player Projectiles layer. Remember, when we create a new layer, we need to modify the collision matrix for better collision control. I want that projectiles collide just with enemies, so disable other collisions. Finally, we can create a script for the laser bullet. Add the script to the object. Open it. Let's create variables. First, we need the speed of the bullet. Then we need the damage variable. This variable will determine how much damage the bullet will do. We also need the rigid body 2D variable. In the start function, we set velocity to transform.up multiplied by the speed. Transform.up is the direction and it is represented by the green axis in the scene. This will make the bullet move up. We don't need the update function. To detect collision with the bullet, we use onTriggerEnter2D. Then we don't need to check what collided with the bullet because of the collision matrix. We know that just enemies collide with the bullet. So from the collision we get the enemy component. Remember that enemy class is a parent class to all types of enemies. So every enemy type has the enemy script as a parent class. In the enemy script we have the take damage function. The take damage function will damage the enemy. Now, when we got the component, we can call the function enemy.takeDamage. The function takes one argument and that is the damage we will do to the enemy. Then destroy the bullet. However, there are cases when bullets will miss enemies. Then we need to destroy those bullets. Same as meteors, we use the onBecameInvisible function. When the bullet is off the screen, destroy it. Now go to Unity. Connect the rigid body component. Set speed and damage. I will set damage to 1. Now drag the bullet to the prefabs folder. Delete this one from the hierarchy. Select the player and drag the bullet prefab from the assets. Let's try it. As you can see, collision is detected, but we don't destroy meteors. There is a simple explanation for that. Select one of the meteor prefabs. You can see that health is 0 and one bullet should be enough to destroy it. Let's go to the meteor script. We are searching for the death sequence function. Remember, this function is called in the take damage function when the health is 0 or less. And we call the take damage function when an enemy collides with a bullet. So everything is connected correctly, but that sequence is doing nothing. It is empty. We just need to destroy the meteor in the death sequence. In Unity, select all meteor prefabs. If you want the meteor destroyed with one bullet, set health to 1. I will choose 2, which means 2 bullets to destroy it. Let's try it. Nice, everything works. See you in the next lecture. Hello everyone, let's create a health and damage system for the player. Through the course, we will upgrade this system with animations, game manager logic and other stuff, but the core functionality is done in this lecture. First, we need a new C# script. I will call it player states. Add the script to the player. Open it. Let's create some variables. We need a float max health variable. This will be the maximum health for the player, which we determine in the inspector. Then we need one private variable health that will represent the current health of the player. In the start function, let's set current health to maximum health. We don't need the update function. Now let's create a function so that the player can take damage. I will call it player take damage and it takes one parameter damage. As you can see, the damage system is similar to the enemy damage system. Here we decrease the health by damage amount. Then check if health is less or equal to 0. If that is true, then we can destroy the player. In the future, there will be a lot more logic here. Animations, spawning explosions, showing the death scene, and so on. Now go to Unity. I will set maximum health to 3. Go to the enemy script. All enemies will deal damage, so it makes sense to create a damage variable in the parent class. In Unity, select Meteor prefabs and notice there is a damage variable in the inspector. I will set the damage to 1. Then open the Meteor script. If you remember, when a meteor collides with the player, we immediately destroy the player. We can comment that line of code. Idea is to damage the player. Now we can get the player stats component. From the player stats, we call the player take damage function. The function takes the damage variable that we created in the enemy class. Let's also destroy the meteor. Now we can try it. The player should be destroyed after 3 meteor hits, since health is 3 and damage is 1. 1, 2, and 3. It's working. Of course, it would be nice to see how much health the player has, so in the next lectures we will create a health bar for the player. Hello everyone, in this lecture we'll learn about UI fundamentals, how to properly set up a canvas, how to properly position UI elements and more. For creating a health bar and main menus, it's necessary to know fundamental stuff. First, let's right-click on the hierarchy, and here you can see all UI elements. The most common are image, text, and button. Let's create an image. This will automatically create canvas, image, and event system. Before we start working with the image, let's select event system. Because we are using a new input system, we need to replace this module. This will enable interaction with buttons and other interactable elements in the future. Now double-click on the canvas to see the full size. By default, the canvas has the same size as the screen. Let's select our image, change position to 0, 0. Now the image is in the middle of the screen. If you go to simulator, you should see the image. The first thing we need to change is to make UI elements scale depending on the device. That means on smaller devices, UI elements need to be smaller and bigger on bigger devices. For example, I will change to a bigger device. Notice that the size of the image is the same. This is not what we need. So to change the size, select Canvas. You should see the Canvas Scaler component. Then change the scale to Scale with Screen Size. Notice that the image is bigger. The next step is to choose a reference resolution. Since this game is for portrait perspective, let's set the resolution to a 9:16 ratio. And we want equally match width and height, so set the match to 0.5. Now, when you change devices, the size should change correctly. Maybe it's hard to see on this square, but with real sprites the change would be more visible. Now let's move on to the most common mistake I see people make. Let's say we need to create a health bar with this image. The health bar needs to be in the upper corner. Let's select the image and move it to the upper left corner. You can see that in the simulator the position is good. However, let's choose a smaller device. Now you can see that the image is off the screen. Why is this happening? The answer is anchor position. Select the image and open the anchor presets. By default, the anchor position is in the middle of the screen. You can see the anchor position on the canvas. How do anchors work? Actually, they are really simple. The distance between the anchor position and the object is always the same, so this distance will be applied for every device. On smaller devices, the distance is too big, so the image is off the screen. Another example, let's say this is our test device and the distance. If we choose a bigger device, the image would not be in the corner. It will be closer to the middle than it should be. The solution is to choose another anchor position. In our case, the anchor needs to be in the upper left corner. Now we use this distance from the upper left anchor to the image. This will work for every device now. So let's choose the upper left anchor preset. We can also hold Shift to set the pivot point to that corner. Now change devices in the simulator and see that the image is in the correct position. Okay, we know how to correctly place UI elements for all devices, which means we are ready to create a health bar. See you in the next lecture. In this lecture, we will create a health bar for the player. To start from 0, let's delete the image from the previous lecture. Now let's create a new image. I will call it health bar shape. We have a sprite for this image. Drag it into the source image field. If we zoom in, we can see that the shape is looking deformed, so click on the Set Native Size button. Now the image has identical dimensions as the sprite. However, if we try to change the height and width, the shape will deform. To fix it, select the sprite, go to Sprite Editor. We will use the 9-slice technique. It's called 9-slice because we divide the sprite into 9 pieces. Look for the green square, then you can pull the green line down. Make sure that it is below the corners. The goal is to separate corners from sides. For this line, make sure that it is above the corners. Then we have left and right lines. You can see that the sprite is divided into 9 pieces. The corners will not stretch and deform, only the sides will stretch. Apply changes. Then select the image and change the type to sliced. You can see the difference. When we change dimensions, the shape doesn't deform. Nice. Let's right-click on the canvas and create a new empty game object. I will call it health bar. Health bar will be a parent object to health bar shape. Let's select the shape, go to Anchor Presets and stretch it. Hold Alt and click on the Stretch button. When we change the dimensions of the health bar, which is a parent object, the shape will adjust. Let's create a new child image object. I will call it Health Background. I will use the square sprite. Let's change the color. Then go to Anchor Presets and stretch it. Move it up one place in the hierarchy so that shape is visible in front. When we zoom in a little, because we have round edges, the background image is visible outside of the edges. If you choose another color, it would be more visible. To fix it, let's just change the dimensions. Then we can create a child image of the background. I will call it Health Fill. We can also use the square sprite and stretch it. Now change the color. I will choose yellow. Then change the image and select Filled. We can see some settings. The idea is to change this fill amount as we change health. First, let's change the fill method from radial to horizontal. This will give us desired behavior. Notice that fill amount has values between 0 and 1. Let's zoom out. Select the health bar and change the anchors to the upper left corner. Hold Alt to also set the position. Adjust the position a bit. Maybe we can change the color of the shape. To make the edges thicker, let's increase the size a bit. For now, this looks good. Let's see how it looks in the simulator. Great. Let's go to the player stats script. First, to get access to UI elements, we need to include the UI namespace. Then we can create one image variable. I will call it health fill. Idea is to change the fill amount every time the player takes damage. Also, it's a good idea to set the fill amount when the game starts. So in the start function, we write health fill.fill amount equals to health. But as I said, the value must be between 0 and 1. So we divide health by maximum health. We can copy and paste that code into the player take damage function, and that is everything we need to code. In Unity, drag the health fill image to the image slot. Let's try it. As you can see, we have full health. Let's take damage. Nice, the health bar reacts. I will add more UI elements to the health bar just to make it look better. It's not essential, so I will create a child image of the shape. Use the icon base sprite and change color. The anchor needs to be middle left. Hold Alt to also set the position and resize the image a bit. It goes to the left. I will call this icon holder. Then create a child image of the holder. Use the health icon sprite and resize it. Anchor presets are relative to the parent, so this needs to be in the middle just as it is. Now we can select the health bar and place it in the right position. It looks fine, maybe the edges should be a bit thicker. We can increase the size a bit. You can play with the settings as you like, every game is different. That's all, and see you in the next lecture. Hi everyone, in this lecture we explore one free asset that will help us adjust UI elements for all devices. For example, every device has a safe area in which elements are guaranteed to show properly. You can click on the Safe Area button to see the safe area for this device. Every device has a different design and different safe zone. Let's change the device. For example, choose Apple XR. Notice that because of different designs, our health bar is not fully visible. So idea is to place the health bar and other UI elements inside the safe area for every device. Luckily, there is one cool asset in the Unity Asset Store. You can Google Safe Area Helper. It should be the first option. This is what it looks like. It is free. So click on Add to My Assets. Of course, you need to sign in to your Unity ID if you didn't. After that, click on Open in Unity or whatever is an option. In Unity, the Package Manager should open. You can see that Package Manager has the option My Assets. On the list should be the Safe Area Helper. Then you need to download it. I already did, so I have a re-download button. After you download the asset, click on the Import button. We don't need the demo scene. If you want to see that example, feel free to include it. But we only need this safe area script. In the project, you should see the script. Now right-click on the canvas and create an empty game object. Let's call it a safe area. Then we need to stretch it across the screen. The safe area object needs to be a parent to the health bar and other UI elements that we need to control. Then add the safe area script. Make sure that conform X and Y are enabled. Now if we press play, the health bar will be in the safe area. We can test it on other devices. Great, it works perfectly. So for example, if we have the health bar in the upper right corner without this asset, it would not be visible at all. But with the asset, it looks just as it should. That's all for this lecture, see you in the next one. In this lecture, we'll learn how to create animations. For example, when objects are destroyed, we use explosion animation. To stay organized, let's create a new folder for animations. First, we need to find the sprites that we will use. In the enemies folder, we can see explosion sprites. Let's use the first one in the scene. Rename it to explosion. We can't see it in the scene because of the order in the layer. We need to increase it. I want this explosion to be visible in front of everything. I think that the player has order 10 and the transparent background is 12. It's a good thing to write down that things. So we need to go higher than that. Let's set it to 20. In bigger and more complex games, I recommend creating and using more sorting layers. Now let's open some animation tabs. Go to Window, Animation, and open the Animation tab. Let's also open the Animator tab. We use the Animator tab for animation transitions in the next lecture. Then make sure you select the object you want to animate. To create animation, click on the Create button. Select the animations folder that we created. I will call this animation Explosion Example. If you take a look at the object, now we have the animator component which has a controller. Those are necessary components for animations. Go to the animations folder. Here you can see the controller and the animation example we created. Next, select the explosion object and drag all explosion sprites into the timeline. Let's see how it looks. We have animation, but it's too fast. We need to slow it down. Select the explosion, expand options, and choose Show Sample Rate. Now you can set frames per second for this animation. By default it's 60, let's set it to 12. It looks much better. However, you can see that animation repeats. We need to go to the animations folder and select our explosion example animation. We need to disable loop time. Nice. It's a good idea to destroy the object after the animation is finished. So let's create a new C# script. I will call it explosion. Add the script to the object. Open it. We don't need the update function. In the start, let's destroy the object with a delay of 2 seconds. Let's test it. The animation runs one time, and after 2 seconds the object is destroyed and we can't see it in the hierarchy. Now we can create a prefab. Delete the object from the scene. Idea is to spawn this prefab when meteors or the player are destroyed. Since all enemies will use this explosion prefab, go to the enemy script. Let's create one game object variable. Now go to the meteor script. In that sequence, before we destroy the meteor, let's spawn the explosion prefab. We can use the position and rotation of the meteor. Let's also spawn it when the meteor collides with the player. Then go to the player stats script. We need to spawn the explosion prefab when the player dies. This is all we need to code. Let's connect things in Unity. Select the player and go to the prefabs folder. Drag the explosion prefab into the empty slot. Do the same for 3 meteors. Let's try it. We destroy meteors and explosions spawn. The same happens when we destroy the spaceship. Great. In the next lecture, we create animations for the spaceship and transitions between them. Hello everyone, in this lecture we create this blinking animation when the player takes damage. First, go to the animations folder, create a new folder for the player animations, select the player, then create animation. Make sure that it is in the correct folder. The animation will be called idle. The sprite we need is in the sprites folder. Usually in idle animations there is some movement of the object we animate, but in this case we will use just one default sprite. Idle animation will be a static sprite. So select the player, place the sprite at the beginning, and I will place the same sprite at 1 second on the timeline. Now let's create one more animation. I will call it damage. Then use the white sprite. I will change the sample rate to 30. Then again use the same sprite. Place it at the 0.06 on the timeline. Since the sample rate is 30, the duration will be a bit longer. You can expand the distance between frames to increase the duration if needed. Now you can see the animation. Just a white sprite. Usually, to preview animation, you can use the preview and play buttons. Next, we need to disable looping for the damage animation. Then go to Animator, select the player. Now you can see idle and damage states. We need to create transitions between them. The orange state is the default animation. Right-click on the idle state and create a transition to the damage state. Do the same in opposite direction. Click on the transition arrow to see some settings. To transition from one state to another, we use exit time or conditions. For this transition, we will use conditions, so we need to create parameters. Open the Parameters tab. Then we can add 4 types. In this case, we need a trigger. Let's call it damage. We will activate this trigger through a script. Now we can disable exit time. We need immediate transition, so set this to 0. For condition, let's use the trigger we made. Note that you can have more parameters and use them as conditions. Now both conditions need to be met for the transition to happen. Of course, we need just the trigger, so delete this example. Then select the transition from damage to idle. Here we will use exit time instead of conditions. If we set the exit time to 1, that means the transition will happen when the damage animation is completed. If you, for example, set the exit time to 0.5, then the transition will happen when 50% of the animation is completed. Set this to 1. The transition duration needs to be 0 for instant change. Now, when we completed the settings in the script, we need to activate the damage trigger when a player takes damage. Open the player stats script. First, we need to create an animator component. In the takeDamage function, to activate the trigger, we use anim.setTrigger. In parentheses, we write the name of the parameter. Make sure you spell it correctly. Let's try it. Don't forget to assign the animator. We take damage and we can see the damage animation. However, if you take damage multiple times in a really short period of time, we can't simulate that at the moment, but in a situation when multiple bullets hit the spaceship, the animation would go into spam mode. The spaceship would be in the damage animation all the time. So let's prevent that. In the script, add one bool variable and set the value to true. Then we first check if that variable is true. Then activate the animation. And here we also need to add an anti-spam function. Let's create an IE numerator anti-spam. Here we set the bool variable to false so that we can't activate the animation. Then we wait a certain amount of time. I will set the waiting time to 0.15. Then reset the bool variable. To call this function, we use start coroutine. Now, when the player takes damage multiple times in an interval of 0.15, the animation will be called only once. You can increase the interval if you like. And that's it for this lecture. We have animation transitions. Hello everyone, in this lecture we create a shooting enemy. This is a great opportunity to implement knowledge from previous lectures, like movement, shooting and animations. But also we learn some new stuff, so it will be a bit longer lecture. Let's start. First, for shooting enemies we use a purple spaceship. Change the name, then set the layer to enemy. Increase the order in the sorting layer. Remember, all enemies go to order 5. Then let's add components, add rigid body 2D, and set it to kinematic. Instead of using polygon collider 2D, we will use two box colliders and then merge them. So add box collider 2D, click on the edit collider button, let's change the shape. Then add another box collider 2D. Again, change the shape. This is not super precise, but it's performance efficient and it will function just fine. To merge colliders, we use composite collider 2D. Select used by composite for every collider. Notice that we have one collider. There are no lines that intersect. Then select the Is Trigger option in Composite Collider. Now let's create shooting points. I will call this left cannon. Move the object to the shooting position. Then duplicate it and rename it to right cannon. Place it on the other side. Let's create a script. I will call it purple enemy. Select the enemy and add the script. Open it. First, this class needs to be a child class of the enemy class. Just to remember, the enemy class has some variables and functions that will be inherited by all child classes, including the purple enemy class. In the purple enemy script, let's create additional variables. First, we need a float variable speed. Then we need shoot timer and shoot interval. Let's create transform variables for shooting positions. Then create a game object variable for the bullet prefab. That's all variables we need. To move the enemy, let's use the rigid body variable that we inherited from the parent class. Set velocity to vector2 down multiplied by speed. To shoot, we need to create a timer in the update function. First, we increase shoot timer by time.delta time every frame. Then we check if that timer is greater or equal to the shooting interval. If that is true, then we can shoot. Of course, we use the instantiate function. Instantiate bullet prefab in the left cannon position. Use quaternion identity for rotation. Then we can copy and paste this code. Just replace the left cannon with the right cannon. After that, we just need to reset shoot timer to 0. Now the enemy can move and shoot. Next, let's resolve when the enemy collides with the player. Since we are using a trigger, we need the onTriggerEnter2D function. First, we check if the object is a player using the compareTag function. Then, through player stats, we can call the playerTakeDamage function. Use the damage variable which is inherited from the parent class. Then we instantiate the explosion prefab. After that, we destroy the enemy. So everything we did in the script is known from previous lectures. That is why I go a little bit faster. Now let's override virtual functions, hurt and death sequence. Later, we will add animation in the hurt sequence. For now, in the death sequence, which is called when enemy health is below 0, instantiate the explosion prefab. Then destroy the enemy. Of course, enemies may not collide with the player, or the player doesn't destroy the enemy. That means the enemy will go off the screen. To destroy objects that go off the screen, we use the onBecameInvisible function. Let's save this and go to Unity. In Unity, we need to set variables. I will set health to 3, then we need rigid body. Damage upon collision can be 1. Then use the explosion prefab that we made. Set speed, for example, to 5 and shoot interval to 1, which means 1 second. Let's connect left and right shooting points. Then we need to create a bullet prefab. So let's go to sprites. We have this bullet sprite. Rename it. It's too big, so let's decrease the scale. I think that this is good. Let's change the order in layer. Then let's create a new layer for collisions. I will call it enemy projectiles. Set the layer to enemy projectiles. Let's go to the collision matrix. Enemy projectiles need to collide just with the player. Ignore other collisions. Now let's add rigid body 2D and change the type to kinematic. Then add circle collider 2D. We can decrease the radius a bit. We need to create a script called purple bullet. Add the script to the bullet. Open it. We need damage and speed variables. We also need a rigid body 2D variable. In the start function, let's get the rigid body 2D component. The bullet needs to go down, so set velocity to vector2 down multiplied by speed. We don't need the update function. Let's damage the player when it collides with a bullet. We use the onTriggerEnter2D function. I think that in Unity I forgot to set collider as a trigger. We will do that later. Here, as usual, we check for the tag player. Then call the player take damage function. Then destroy the bullet. We also use the onBecameInvisible function to destroy the bullet when it goes off the screen. That's all for the bullet script. In Unity, set damage and speed. Also enable the isTrigger option. We can create a bullet prefab. Delete one from the scene. Now select the enemy and use the bullet prefab. Let's try it. Move the enemy up and press play. It works. Nice. Now we need to create animations for the enemy. We will need this animation window. Select the enemy and create animation. I will call it enemy idle. Use the purple enemy sprite. Let's create one more animation and call it enemy damage. Use the white sprite. Set samples to 30 and again use the white sprite. Go to the animations folder, select enemy damage and disable loop time. Now go to the animator tab. This is good practice for animation transitions that we covered in previous lectures. Let's create 2 transitions. Then create one parameter damage. Select the transition from idle to damage. Use the parameter as a condition. Duration needs to be 0. And disable exit time. For another transition, leave exit time and just change the duration of the transition to 0. Go to the purple enemy script. Actually, let's go to the enemy script. Usually all enemies use an animator, so let's create one animator component. Then go back. In the herd sequence, activate the transition with the trigger. In Unity, select enemy. We need to assign the animator. Scroll down and you will see it. So expand this and use the animator. Let's try it. It's working. Nice. We can also create an anti-spam function for the enemy just as we did for the player, but I will show you a different approach. In the animator tab, under layers, you can see the base layer. His index is 0 and we will use it in the script. Then select the enemy damage state. In the inspector, you should see the tag field. Use the DMG tag. Back to the script. First, we check if the animation is already running. We use the function getCurrentAnimatorStateInfo with the index of the base layer. Then check if that animation has a tag, in this case DMG. If that is true, that means the animation is currently running, so just return, don't activate it one more time. This is a bit different approach for the same thing. That's all we need to code. There is just one more thing to do. We need to create a purple enemy prefab. And now we are done. We have shooting enemy. See you in the next lecture. Hi everyone, welcome to the enemy challenge. Your challenge is to create a second enemy spaceship. The spaceship needs to have a similar behavior to meteors, just a bit faster and with damage animation. This is a good practice to remember everything we learned in the previous lectures. Okay, I will select the green enemy prefab. You can see that he needs to be on the enemy layer. The sorting order needs to be 5. Maybe if you want to make sure that spaceships are in front of meteors, you can increase it, or decrease meteors to 4. You can see we have the green enemy script, we have kinematic rigid body, we have 2 colliders and a composite collider, and we have an animator for animations. Now open the script. First, the enemy needs to be a parent class. We use one variable speed. As usual, we set the speed in the start function. For collisions, we use the onTriggerEnter2D function. Then we use the hurt and death sequences. Basically, it's a copy-paste code from the previous lecture. I just deleted the shooting part. In the end, we have the onBecameInvisible function. In Unity, let's see animation transitions. We have 2 animations and transitions, just as in the previous lecture. Settings are the same. Now, when we have 2 enemy types, let's create an enemy spawner in the next lecture. See you there! Hello everyone! Now, when we have enemy prefabs, let's create a spawner. First, let's create an empty game object. Reset the transform component. Next, let's create the enemy spawner script. Add the script to the object. Open it. Since this is a spawner, we can use some code from the meteor spawner. Remember, first we need to ensure that objects will spawn outside the screen. So go to the meteor spawner. Let's copy this part that we use for spawning positions. We also need to copy-paste the setBoundaries function. Nice. To organize the script, let's use the attribute header and name it enemy prefabs. Let's use an array of game objects for enemy prefabs. Then we need a float enemy timer. Then use the attribute space to create space between variables. We need a float variable enemy spawn time. Then let's create a function that will spawn enemies. First, let's increase the timer by time.deltaTime. If that timer is greater or equal to the enemy spawn time, then we need to spawn enemies. Since we have 2 enemies, let's randomly pick one. Use random.range between 0 and enemy length. This will ensure that the code works with any number of enemy prefabs. Then instantiate the enemy using the random pick index. For position, we use new vector 3. For x coordinate, use random.range between max left and max right positions. For the y coordinate, let's use y position, and for the z-axis we can use 0. This is the same procedure as before. For rotation, we can use quaternion.identity. After that, we reset the timer. Call this function in update. That is all we need to code. Let's go to Unity. Let's assign enemy prefabs. Then we can spawn an enemy every 2 seconds. Let's try it. We can see the purple enemy. And we can see the green enemy. Nice. That's all. See you in the next lecture. Hi everyone, in this lecture we create win condition. The idea is that the player survives a certain amount of time and after that the game ends. First, let's create a new game object. Then we can create a script. I will call it win condition. Add the script to the object and open it. We need a float timer. Then we need a float possible win time variable. We also need an array of game objects that we will use for spawners. In the update function, let's increase the timer by time.delta time every frame. Then check if that timer is greater or equal to possible win time. If that is true, that means that the player survived and we can deactivate spawners. We use the for loop. Counter I is 0. We go through the loop while I is less than spawner length and increase I by 1 each step. In the loop, we deactivate the spawner with index I. Just to more explain this loop, let's say we have two spawners in the array. Indexes are 0 and 1. The length of the array is 2. So counter I will be 0 at the start. Then we check if 0 is less than the length of the array, which is 2 in our example. This is true, so then we deactivate the spawner with index 0. Then increase I by 1. 1 is less than 2. We deactivate the spawner with index 1. Increase I by 1. Now 2 is not less than 2. We exit the loop. After we deactivated spawners, some of the enemies are still on the screen. Because those enemies can still destroy the player, I call this a possible win time. We need to create a function that will check if the player is alive after all enemies are off the screen or destroyed. Then we could show a win or lose screen. All that we will do through Game Manager. I write this code in comments to remind you and myself what needs to be done in another script and then call it here. In the next lecture, we will create a panel controller that will manage win or lose screens. For now, go to Unity. Let's say that the possible win time is 10 seconds. Then we need to add spawners to the array. We have enemy and meteor spawners. I will just organize the hierarchy a bit. Let's test it. Survive 10 seconds and then enemies should stop spawning. I will try not to die. Great, you can see that spawning stopped. The next step is to create win and lose panels, which we do in the next lecture. See you there. Hi everyone, let's create win and lose screens and a script that will have functions to activate those screens. First, let's create a new image. I will call it panel. Note that this image doesn't go into the safe area. Next, we can use the square as a source image. Then we need to stretch it. Then change the color. I will use black. And let's make it a bit transparent. Then let's create a new image. It needs to be a child object of the panel. I will call it win screen. For the source image, we will use this large panel sprite. Note that I already did 9 slice. Check the health bar lecture for more information about Night Slice. Let's use the sprite. Make sure that the image type is sliced. Then we can change the dimensions. The image needs to be in the middle of the screen. Let's see how it looks in the simulator. This is good, you can change it as you wish. Now let's add text to the Win screen. Select Text Mesh Pro. This is the first time we use text, so we need to import Text Mesh Pro. Let's rename it to Win Text. Then let's just write Win. This is not the final look of the Win screen, this is just a sketch and placeholder. For now it's about functionality, and later we will add more text with the real font, buttons and other UI elements. Then let's duplicate Win screen. Call this Lose screen. Change the text to Fail. Okay, now we have basic Win and Lose screens. Let's select the panel and now add the Canvas Group component. Canvas Group has some cool options that we can control. For example, we can change the alpha settings for all objects in the group. These screens will have buttons, so in order to press them and interact with them, we need to leave interactable and block raycasts enabled. We can set the alpha to 0. Then let's also disable Win and Lose screens. Let's create a new empty game object. I will call it Panel Controller. Then let's create a folder for UI scripts. Create a new script, Panel Controller. Add the script to the object and open it. First, we need the Canvas Group variable. Then we need two game object variables, one for Win screen and another for Lose screen. We don't need the update function. Let's create a function that will activate the Win screen. First, we set the alpha value to 1. Then we activate the Win screen. Let's also create a function that will activate the Lose screen. It's a similar procedure. For now, that's all we need to code. In Unity, let's connect components and objects with the script. We need the Canvas Group component from the panel object. Then connect the screens. Now the question is when and how to call functions that will activate those screens. Maybe you are thinking, let's connect Panel Controller and Win condition. Don't do this. Instead of making a direct connection between them, we will create a game manager. This is a kinda preparation lecture. In the next video, we connect all of this through the game manager. See you there! Hello everyone! In this lecture, we create a game manager. A game manager is a script that controls important aspects of the game, and it is used in many other scripts to help run the game correctly. First, let's organize the hierarchy a bit. Let's create a new empty game object. I will call it managers, since we will have different managers in the game. Next, again create a new empty game object. I will call it End Game Manager. This manager, as his name says, will be responsible for controlling functionality when the level ends or the player dies. Let's also create a managers folder for scripts. Create a new script and call it Endgame Manager. Add the script to the object and open it. Since this game manager will be used in many scripts, we need to create a static instance of this class. So we write public static, then the name of the class, which is Endgame Manager. Then we choose a name for this instance. I will call it EndManager. This is just an empty variable now. We need to assign value. In the awake function, which is called before the start function, we set the instance EndManager to this class. Now everything that this class contains, variables, functions, and so on, we can use it with the EndManager instance. Note that the keyword static gives us easy access to other scripts. What does mean easy access? I will show you a very simple example. Let's create a public bool variable game over. Now let's go to the player stats script. When the player health value is less or equal to 0, that means that the game is over. So we can just write endGameManager.endManager.GameOver and set the variable to true. Note that there is no direct connection between the player stats and game manager scripts. I don't need to use getComponent or connect anything in Unity. This will function as it is. Now let's add functionality to the Endgame Manager. We need two functions, win game and lose game. Make sure that they are public, so we can call them in other scripts if we need them. In the win game function, we need to activate the win screen, unlock the next level, save the score, and so on. For now, let's just activate the win screen. Let's go to the panel controller script. Remember, in the panel controller script, we made functions that will activate screens. So we need a way to use them in the game manager script. Now I will show you the structure we are building. You know that in the scene we have Endgame Manager and panel controller. The controller has some functions that control UI elements. We also have the win condition object in the scene. In the win condition script, we need to call functions that will activate UI elements. We also have a player in the scene, and we also need to activate UI elements from the player stats script. We could directly connect player controller with those objects in Unity Inspector or use getComponent, but we want to avoid that. It's not practical, and as your game expands, there will be more and more objects and everything will be directly connected with everything. It's a mess. We just need to connect controllers, in our case panel controller, with the game manager. And since the manager is static, it has easy access to all scripts. Notice the advantage, everything goes through one channel, and that is the game manager. The trick is to efficiently connect the manager and controllers. Instead of the manager looking for the controller will register itself to the manager. So in the manager script, let's create the panel controller variable. Then we can create a public function for registration. Register panel controller. It will take one parameter, panel controller. In the function, set the panel controller variable to PC. Now go to the panel controller script. In the start function, let's call the registration function that we made. To the function, we will pass this class. Notice how this is easy because the manager is a static class. Now in the manager, we can use the panel controller variable to activate UI elements. Now let's create the resolve game function. If the game over is false, then we can call the win game. Or else we can call the lose game. Now go to the win condition. When the time expires, we deactivate the spawners and we could directly call the resolve game function. This would function correctly, there is no error here, but we have a small problem. When we call the resolve game function, there is a chance that there are still some enemies on the screen. Those enemies could destroy the player. So we need to introduce some delay between deactivating the spawners and calling the resolve game function. Back to the manager script. For delay, we use coroutine functions. Let's create the IEnumerator resolve sequence function. We can wait for example 2 seconds. Then we will call the resolve game. Now create a public start resolve sequence function. Here we use start coroutine to call the IEnumerator function. This is the function that we will call in the win condition script. Note that after the timer reaches possible win time, this condition will be met every frame. It will constantly run this code. So we just disable this game object after the first run. Nice, let's try it. We need to survive 10 seconds, then the spawners will deactivate, and after that we have 2 extra seconds before the win or lose screen appears. It depends did we survive those 2 extra seconds. As you can see, it works. Now let's go to the player stats script. After the player is destroyed, we also need to call start resolve sequence. To avoid multiple calls from different scripts before we start the coroutine, let's stop the coroutine if it's already active. Use stop coroutine. We need to pass a string, but we can use name of and choose resolve sequence. Let's try it. Destroy the player and we should see lose screen. Great, this is all for this lecture, see you in the next one. Hello everyone, let's upgrade the endgame manager script with the singleton pattern. A singleton pattern means that can be only one object of the same type in the whole game. That means we should have only one endgame manager in the entire game. This is very useful for static classes since we need to be careful about performance. At this point we have one scene, let's call it level 1. Now duplicate it and call it level 2. When we go from one scene to another, all objects from the previous scene are destroyed. For example, we go from level 1 to level 2, all objects from level 1 are destroyed, and Unity loads new objects that we have in level 2. Connecting all scenes together, we get a game. When a player plays the game multiple times, he can start it on different levels. The idea is to somehow preserve the manager from the level where the player started. By default, we have some objects in every scene, and every scene has the endgame manager object. So let's go to the endgame manager script. In the awake function, first we check if the instance is null. Then set the instance to this class. Then we use the don't destroy on load function. We don't want to destroy this game object. Just to show you, I will run the game. Click on the pause button and you can see that the endgame manager is placed in another scene called don't destroy on load. Let's say we started the game on the first level. We go to level 2. All objects except the endgame manager will be destroyed because of the don't destroy on load function. This manager will go to the level 2. But now we have two game managers, one from the first level and another that was by default in the second level. We need to destroy one from the second level. In the script, use else, which means that the end manager instance is not null. Then destroy this game object. So the game manager from level 2 will run the awake function, and the instance of end manager will not be null because it will detect it from the manager that came from level 1. So in our example, the manager from level 2 will run this part of the code and destroy itself. And that's it, we created a singleton pattern. In the next lectures, we will learn how to switch between scenes. See you there!